right, chapter 2, section 4, continued. So we'll do pages 1 and 2 of the notes in this video. The average rate of change of a function. Now, we already saw the difference quotient. And this is similar because it really is slope. And the difference quotient was it was a quotient. It was a ratio. It was a ratio of two things, like slope. Average rate of change of a function. And that difference quotient, that was, we found the difference quotient when we were given the two function equations. Well, actually, it was one function equation. You had to evaluate the function at f of x plus h. This is a little bit different. This, we're going to find the average rate of change, which, again, is still slope. Of a function when we're given, say, two x values. So the most common rate of change that we're familiar with for linear functions, again, is slope. And we talked about that when we talked about the difference quotient. If the graph of a function is not a straight line, we speak of an average rate of change between any 2 points on the graph. So it's an average rate of change. All right. So we have a diagram on the note sheet here. I'll talk about that in a moment. To find the average rate of change, we must calculate the slope of the line that contains the 2 points. And that line is called the secant line. Secant line is a line that passes through 2 points, if you remember from geometry. All right. Also from geometry, if you remember, the tangent line is the one that just touches or bumps up against it. But this is not a tangent line. This is a secant line, passes through 2 points. So here, let x sub 1, comma, f of x sub 1, and x sub 2, comma, f of x sub 2 be distinct points on the graph of the function f. And we can see that here in this diagram. This is x, the value of x sub 1. This is the value of x sub 2. This ordered pair right here would be x sub 1, comma, f of x sub 1. And there's my x sub 2, comma, f of x sub 2. Folks, these are just ordered pairs. x1, y1. It's in function notation. And this is x2, y2. And we can use those to find the slope. So the average rate of change from x1 to x2 is this. Change of y over the change of x. Okay, delta y over delta x. These are the y's, f of x sub 2. Remember, f of x takes the place of y. All right, so here is my function. I know it's a function. It passes the vertical line test. All right, that's my function. These are my two ordered pairs. And when I draw a line through them, I can find the slope of that line using those values. Now, of course, we're going to know the x's. We don't know the y's. We're going to have to calculate it. And you're going to see that in the next example. All right, here. Y equals f of x. There's no values on here. It's just textbook notation. All right, if you have any questions on that, you know what to do. Post on the discussion or ask in class. All right, here's what we're going to do with this. Find the average rate of change of f of x equals x cubed from 3 parts here. 0 to 1, from 1 to 2, and from -2 to 0. We're actually going to do this algebraically And then we're going to look at it graphically and compare our results is what we're going to do here right now. All right, so find the average rate of change. I like to either circle or highlight my function because sometimes these are more than one term. This one here happens to be just one term, x cubed. But sometimes there's more going on, and so you're going to want to circle or highlight the whole entire function equation. All right. What do I have? I'm given the function, and I'm given two x values. I have to compute and find the y values. I have to find f of x sub 1, and I have to find f of x sub 2. Right? I'm really finding f of 0 and f of 1. F of 0 and f of 1. So I'm going to use my function to do that. It's something cubed, something cubed. The something is 0 and this something is 1. 0 cubed is 0. 1 cubed is 1. Does it always work out this way? No. All right. My slope formula is really y2 minus y1, written in function notation, over x2 subtract x1. F of x sub 2 is 1, subtract. F of x sub 1 is 0. X sub 2 is 1. X sub 1 is 0. This is 1 minus 0, which is 1. Same thing in the bottom. And so I see that the average rate of change on the x cubed function from 0 to 1 is 1. So the secant line has a slope of 1. Okay, we're going to do the same thing for parts B and C. Again, what do you do with these types of problems? Well, you have to compute, you have to find the y's. F of x sub 1, f of x sub 2 is really finding f of 1 and f of 2. F of 1 we know is 1 cubed, which is 1. F of 2, remember I'm getting this from the original function. I'm going to cube a 2 and get 8. All right, now notice, from 0 to 1, my slope was only 1. I'm clearly seeing that something bigger is happening here from 1 to 2. So it's appearing as though there's a much steeper slope on this one. F of x sub 2, subtract f of x sub 1, that's really my change of y. Over change of x, f of x sub 2 is 8, subtract 1, over the originals, 2 subtract 1, 8 subtract 1 is 7, 2 subtract 1 is 1. Average rate of change now on the graph of the cube function from 1 to 2 is much steeper. The slope is 7. We'll see what happens from -2 to 0. Again, you have to compute the y values by actually finding f of -2 and f of 0. When I cube a negative, it's negative. When I cube a 0, it's still 0. All right, set up. I like to write my formulas over again because I feel like I learned them better because I have memories of writing it over and over and over again. Would you be given this formula on a test? I don't think so, because you would just have to know that this is slope. So it's change of y over change of x. They give you the x's. You have to find the y's to be able to do this. All right, f of x sub 2 is 0. Subtract, what is f of x sub 1? That's negative 8. What do we got for our x's? 0, subtract, negative 2. This is 8 divided by 2, or 4. So the average rate of change on the graph of the cube function from negative 2 to 0 is 4. All right, so now what we're going to do is graph this and actually show you and prove that this is true. All right, so for the 3 graphs, we are going to graph 3 times. F of x equals x cubed. F of x equals x cubed. F of x equals x cubed. I like to graph it 3 times. Later on, we are going to get into graphing and transformations of functions, and it would behoove you to know the ordered pairs on the cube function. All right, a no-brainer. 0, 0 is on it. 0 cubed is 0. 1 cubed is 1. Negative 1 cubed is negative 1. So those 3 dots on the diagonal are always on the cube function, the parent function of the cube function. In other words, there's no transformations, no moving up, down, left, right. Okay, so your basic cube function has those 3 points as ordered pairs. And then I'm going to choose 2 more because, this looks like a line, and it's not. It's the cube function, x to the power of 3. Now I'm going to take a 2 and cube it, and I get 8. We saw that up here. 2 cubed, oops, right here. 2 cubed is 8. So I'm going to go where x is 2, and I'm going to go up 8 units. 1, 2, 3, 4, 5, 6, 7, 8 up here. And negative 2 cubed is negative 8. So I'm at 1, 2, 3, 4, 5, 6, 7, 8, somewhere about there. All right, I'm going to do the same thing over here. 2 cubed is 8. Negative 2 cubed is negative 8. 2 cubed is 8. Negative 2 cubed is negative 8. I'm now going to connect. Cube function takes on this look. Okay, we're going to do it 3 times. And 1 more time. All right, there are my 3 graphs for the cubes. Now, I'm going to draw the secant line. The first graph was from x1 equals 0 to x2 equals 1. I'm going to put a dot here and a dot here. I'm going to draw the secant line that connects those 2 points. And now I'm going to look at the slope of this line. From this point to this point, I rise 1 and run 1. Rise and run 1. Rise and run 1. So guess what? The slope of this is 1, which matches the algebraic computation of the slope of the secant line. All right. From, maybe I should do this one in a different color. From x1 equals 1 to x2 equals 2. All right, so where x1 is 1 is here, where x2 is 2 is here. And I'm going to draw my secant line and calculate the slope. From this point to this point, I'm going to rise 1, 2, 3, 4, 5, 6, 7, and run 1. The slope is 7 over 1, or 7. And again, that matches what we found algebraically right here. Last one, I'll go back to the green. From x sub 1 equals negative 2 to x sub 2 equals 0. All right, so which point is x is negative 2? This one down here. And 0, that's this one here. So I'm going to connect those 2 points, draw my secant line, use my rise over my run. So from this point to that point, I'm rising 1, 2, 3, 4, 5, 6, 7, 8, and I'm running 1, 2. That's 8 over 2, which is what we saw here. That's 4. So really, all you're doing is finding the slope of the secant line, and that's giving you the average rate of change of a function. If you have any questions on it, please ask. The next part here of the video, that the lesson that we're going into, is odd and even functions. Folks, we do a lot with odd and even in this course. So pay attention to that. I'm going to show you the algebraic way, which is the preferred method of use. And then I'm going to show you the easy way after I go through the algebraic. All right, the function of f is an even function. We're going to want to know later on. You're going to have to graph using leading coefficient test, and you won't be able to use a graphing utility to do this. And we need to know, is the function even or odd? Because the end behavior of the graph depends on knowing whether the function is even or odd. And then later on, we're going to talk about the leading coefficient, whether it's positive or negative. So if we look here, you know, in the cube function, the ends of the graph are going in opposite directions. You know, we're falling on the left and we're rising on the right. If you think of a parabola, okay, the parabola, which has this shape, okay, the parabola, the ends of the graph go in the same direction, either both up or both down, okay? So it's important for us to know what we're talking about when we are thinking about odd and even functions, because it's going to have a practical use for us later. All right, so the function of f is an even function if f of the opposite of x equals f of x for all x in the domain of f. All right, so what do we do? When evaluating f of x at f of the opposite of x. We did that, okay? Remember you had to evaluate f of 2, f of x minus 1, and then f of the opposite of x. So when evaluating the function at f of the opposite of x, you will get the same function. And we're going to see that when we do practical examples down below. You get the same function result. That happens if the function is even. So if even, you get the same. The function of f is an odd function. If f of the opposite of x equals the opposite of f of x for all x in the domain of f. Let me underline that in purple. So when evaluating f of x at f of the opposite of x, you will get the opposite function. You know, when you take the opposite of x, it's negative x. When you take the opposite of 2, it's negative 2. When you take the opposite of x plus 1, it's negative x minus 1. So you're going to get the opposite function out. And I always remember it, you know, O for odd, you know, it starts with the letter O. Comma, O for opposite. All right, now if I look at this notation, I mean, really, think of this logically. When the x's are opposites, the y's are the same, right? So if I cover up, like, you know, this negative x and this positive x, I see positive f equals positive f, right? So when the x's are opposite in sign, the y's are the same. But here, when the x's are opposites in sign, the y's are also opposites in sign. We see that up here, the cube function is an odd function, right? It's power of 3, and 3 is odd. So if I'm looking and comparing these two ordered pairs, this ordered pair is 2, 8, and this ordered pair is negative 2, negative 8. So when the x's are opposites, so are the y's. Okay, and that's what's going to happen. And that's really what this means here. But if you're asked to compute this algebraically, this is really what you're going to do. Identifying each of the following functions as even, odd, or neither. So if neither one of these things happen, then you have to say the function is neither even nor odd. All right, number 1. You're going to have to evaluate the function at f of the opposite of x. So I'm going to take this and evaluate it at f of the opposite of x. The original function is x squared plus 6. There's my x squared plus 6. I'm going to substitute the negative x in there. When I square a negative, it's positive. So I get x squared plus 6. So f of the opposite of x equals x squared plus 6. Folks, if I compare these two, they are exactly the same. F of x equals f of the opposite of x, right? X squared plus 6 equals x squared plus 6. This function is even. So we say since f of the opposite of x equals f of x, the function is even. Is she going to do the announcements or what? Kelly, are you doing the announcements or what?
time, please rise for the Pledge of Allegiance. I pledge allegiance
to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Please remain standing for a moment of silent meditation. Please be seated. Today is Thursday, January 14th. Have a great day.